Okay, so we are still trying to do A through J for the function on the next page. This is like what we did on the last problem. The difference is this new problem is not factored for us. So we are going to have to figure out how to get it factored. Well, let's do that before we do anything else. So the numerator, we could definitely factor that one. Let's put it up here so we don't have to waste some space. Factors of -6 that add up to 1 would be a 2 and a 3, where the 3 is positive and the 2 is negative, right? I believe so. So look at the denominator. You should think factor by grouping. If you factor x squared out of this, you're left with x plus 6. There's no way to factor this so that you're left with an x plus 6. That means we're going to have to use those p's and q's that we learned in the last section. So for x cubed plus 6x squared plus 3x minus 10, p is -10, q is 1. We need factors of both. Factors of 10 are 1, 2, 5, and 10. Factors of 1 are just 1 and 1. So when we do p over q, we put all of these over 1, which means we pretty much just get that list, right? So from there, we start testing them. Once do x enter, type in the function. Oh, we got 0 right away. So we stop. We know 1 works. 3, 2, 1, 0. So 1, 6, 3, -10. Bring down the 1 and multiply. Add, multiply, add, multiply, add. That's a good thing. So now we need to rewrite this. We know it's x minus this number, and then reduce this by 1, which gives us an x squared and an x. That would be x squared plus 7x plus 10. There are factors of 10 that add up to 7. That would be 2 and 5, and they're both positive. So the denominator will factor into this. So our function in factored form is going to be x minus 2, x plus 3, all over x minus 1, x plus 2, x plus 5. So I'm going to keep this in mind, but know that I can use this form of the function if I need to. Now we can start answering all the questions. The first question is, what's the domain? For the domain, it's where the denominator equals 0. So x minus 1 can't be 0, x plus 2 can't be 0, and x plus 5 can't be 0. So x can't be 1, x can't be -2, x can't be -5. Sometimes for this kind, it's better to look at it on the number line. So we have -5, -2, and 1, right? So it's all these, it's all these, it's all these, it's all these. So to write the domain, we have -infinity to -5, -5 to -2, -2 to 1, and 1 to infinity. This is our domain. Then next would be to find any holes or removable discontinuities. Well, that happens when you can reduce it. Can we reduce this? Nope, so there are no holes. Alright. Find all vertical asymptotes. Vertical asymptotes are where the denominator is 0. So for this one, we have x equals 1, x equals 2, negative 2 actually, and x equals negative 5. These are our vertical asymptotes. Let's go ahead and put those on the grid. We have a vertical asymptote at 1, negative 2, negative 5. So 1, negative 2, and 3, 4, 5, negative 5. 3 vertical asymptotes this time. The next thing is to find all horizontal asymptotes. A horizontal asymptote, in this case, look at the original, this degree is less than this degree. This is degree 2, this is degree 1. Sorry, this is degree 3. When your numerator's degree is less than your denominator's degree, the horizontal asymptote is just y equals 0, which is the same thing as your x-intercept, your x-axis. Sorry, my words are, actually my brain's not working properly. Alright, what about the next step? Find all oblique asymptotes. Well, oblique asymptotes happen when this degree is 1 more than this degree, and that's not happening, which means there are no oblique asymptotes. Okay. Next, we're supposed to find all of our x-intercepts. I'm going to use the factored form to find that. For the x-intercept, remember you let y equal 0. So you have 0 equals all this stuff. To solve that, multiply both sides by the common denominator. Hopefully you see a pattern forming with that. When you multiply the left side, you get 0. When you multiply the right side, all the denominator goes away. So you just have x minus 2, x plus 3. Set them both equal to 0. Add 2, so x equals 2. Subtract 3, so x equals negative 3. Your x-intercepts are the points 2, 0, and negative 3, 0. Let's go ahead and put those on our graph as well. 2, 0, and negative 3, 0. 1, 2, 3. Negative 3, 0. Okay, next we want to find the y-intercept. To find a y-intercept, you let x equal 0. Let's go to the original problem. If x is 0, we have 0, 0 minus 6, 0, 0, 0 minus 10. So we get y is equal to negative 6 over negative 10. Negative over negative is a positive, and 2 will divide into both of these. So our y-intercept is the point 0, 3/5. So we have 0 and a little bit more than a half, something like that. We need to find a few more points on our graph. So remember, this time we have 1, 2, 3, 4 sections. We need at least 3 points in each section. So 1, 2, 3, 4, 5. I think I'll pick negative 5.5 and negative 6. And then I'll go maybe 1 or 2 more. We can do negative 7 or negative 8. That'll give me 3 in that first section. In the next section, I already have 1 point. So what I might do is just pick something really close to each asymptote. So that's 1, 2, 3, 4.5. Negative 4.5. and that was -2.5. That'll give me 3 points in this section, and I'm going to do the same in this section. So that would be -1.5 and maybe 1/2. And then on the last section, I just need something close and something far away. So this would be 1.5 and then maybe like 4. Phew. Okay, let's put all of those into our function. So remember, you do -5.5 and store it. That's this one. I'm going to go back up here and use my original function. So I'm going to have x squared plus x minus 6 divided by x cubed Let me double check that. I think that's right. So now that I have it in there, I don't have to go back to the top of the page and type it in again. This gives me about -1.6. So we store -6, recall the equation, that's about -0.9. So we just get these values for each of our x's. And you want to be able to do this kind of quickly because you don't want this table to take up too much of your time. So we have -0.5. Oh, that's 0.9. 0.09. Okay, so what I'm going to do next is plot all of these on my coordinate plane. 1, 2, 3, 4, 5.5, 1.6, -6, -0.9, 6, 7, 8, -0.3. So this one looks something like this. Anytime you want to be even more exact, just put more values in your table so that you get more points on your graph. So then we have 2, 3, 4.5, 1.4, -2.5, -0.5. So this one looks like it might be doing this. Kind of missed that point, but you get the idea. And then we have -1.5, 1.2, 0.5, 0.8, 0.8. What was this point? That was 0.6. It's about right there. I don't know what's happening over here. I don't know if it's going back up or if it's going down. So what I need to do is get another value in here. Oh, my bad. That was a positive 0.5. So positive 0.5, positive 8 is over here. So we do know what's happening. It's going back up again. So that one looks something like that. Alright, so then we have 1.5, -0.2. And then 1, 2, 3, 4. Really close. I have no idea what's going on that side. So what I might do is plug in 1, 2, 3, 4, 5, 6. Maybe I'll plug a 6 in there. That really didn't help me very much, did it? So it's something like that. So for this one, just so I can get kind of an idea of how I should draw this side, I'm going to go here and graph it. So it looks like what's happening is it's coming up. Oops, that's supposed to be straight. And it looks like it's just doing like this. Really, really, really close that way. Which is what those values look like anyway. It's not going straight, it's just getting really, really, really close to the x-axis over here. So we have our graph.